This video will be looking completely into gRPC with Golang and how does it actually work. And we'll also be looking into Protoc Buffers and how it interconnects with gRPC and Go. So we'll also be building a project on this. It's a very small project, but I think it would be giving you a very good insight into what's how it happens with gRPC. So let's get into it. Before even going into gRPC, we need to learn its competitor, which is REST. So REST is usually what we do, like we have roots in any of the language and we call it as REST API. And usually how it goes is that it has a browser and it has a server, and request and response comes and goes. So we have a single request and a single response comes back. And if there are like multiple request and responses, that goes into a different kind of topic where it's kind of like WebSockets kind of thing. So let's see what gRPC is. So before that, I know this is like a complex diagram if you may have seen this on the internet, but before even going into this diagram, what I want to say is that gRPC stands for Google Remote Procedural Call. The main advantage of gRPC is that it can be used with many languages, and it can be used with if you integrate gRPC with Protoc Buffers, then you can like write code, or you could structure your code very well and you could integrate it with any language. So that's the plus point of using gRPC. In this diagram you can see we have a Go service, and this Go service has a gRPC server, and there are some clients. Each server has client, so client is what contacts the server. And we have a C++ client, and we have a Java client, and we have something called gRPC stub. So we'll be talking about this a bit later, but what happens is that we send a request and we receive a response. This is not this traditional kind of request and response, but this is like more like a function call, where the client calls a function which is present in the gRPC server. So that's how it happens. So in this diagram, different language clients are contacting our gRPC server, and they're also receiving response to that. So let's get started with gRPC. So in gRPC, even for function calls, we have 4 different types. So different types of what? Different types of services. So gRPC offers 4 kinds of services, which are we mostly use unary, which is in this diagram. I think you might have guessed what is going on in this diagram. We have a request and then we have a response. It's just a single function call, and we receive a single response from the server. We don't receive any more responses, or we don't receive any more than one request. We don't. So that's what unary. Unary stands for single. So we have a single client and single server, and a response and request and response. So that's simple. And if you go a bit down, there's something called client streaming. So in gRPC we have a concept called streaming. So streaming, in the sense we can send multiple number. So more than one is called as streaming. In REST API you can take WebSockets as an example, because you will be sending multiple streams of events. So that's an example from the REST API. But in gRPC we have streaming. So we have client streaming and we have server streaming. And if the client streams, then it's called as client streaming. Client streams in the sense client might send multiple requests, which is more than one request, but after completing all these requests, or you can say after receiving all these requests, the client receives a single response, which indicates the end of this request and response cycle. So that's what is known as client streaming. So you can say we have multiple boxes here, each corresponding to a single request. So we have multiple requests. We don't know how many. It might be one, it might be more than one, but it's multiple. The third service is server streaming, and server streaming is quite opposite to what we have seen before for client streaming. So in this case, the client will be sending one request, but we will be receiving multiple responses from the server. In this case, we are receiving a stream of responses from the server. So a request will be single, but we can receive more than or one, you would say, responses. So that's what server streaming is. And finally, we have bi-directional streaming. So in this case, we have streams of requests and responses coming from both the sides. So this kind of makes like a WebSocket. So it's not exactly WebSocket, but you could say this is an mimicked version of WebSocket. So we have these 4 entities. Let me zoom in. We have these 4 entities: unary, client streaming, server streaming, and bi-directional streaming. And we'll be seeing how this can be used in our application. So when we will be seeing this when we build one. Now that we have known about gRPC, let's dive into protocol buffers. I just want to give a quick introduction of protocol buffers. What is protocol buffers? So you could say protocol buffers is kind of a structured way to make the interaction between client and server. So in this case, the client is sending a request and a response, right? So this request and response is very specific in the sense it is very strictly defined in the protocol file, and this request and response should obey what are all present in this proto buffer. So that's why this protocol buffer exists, to control what request and response is being sent between the client and the server. So here the use of a proto file is that it is what we are seeing in this this diagram. So we have different clients. You can see C++ client and Java client. So how do we actually build clients? Do we build for different languages? When we are building for different languages, do we need to write code separately for them? That's where proto buffers come into play. It's actually not needed to, there's no extra code needed, because we'll be compiling this single proto file into multiple language specific files. So when you compile a proto file, it can be used with that specific language. So in this case, there's a .proto file which we will be writing or defining the request and responses, and it would be compiled using this plugins we'll be using. In this case, we are using a Go plugin because we're going to be writing code in Go, and you could either use C++ or JS or many more languages. So you could use any of them. So let's take an example. Let's say there is a book, and we are writing a definition for book in a proto file. So when we write a book.proto file, and we write all the definitions in it, and we compile that with our Go compiler, and it will be creating two different files. So one, it would be book.pv.go and book_grpc.pv.go. This will be automatically generated using our after compiling. So we'll be seeing how this is useful. Let's take how protocol buffers actually works. Let's say we have a book, and we are defining that book in a proto file. Okay, and let's say that this the name we are giving for this message, we say message for a structure in protocol buffer. So let's say it's a book request. So this is a request will be the client will be sending to the server. This request should contain all this information. So you could how you define let's say a field in protocol buffer is that first you give the type of that variable, and then the variable name, and then you'll be giving an integer number which is unique to this field, and it should be in sequential order. Eventually protocol buffers are serializable, which means they can be converted into binary and then into the original code bank, so and vice versa. So we can define these numbers so that they store the order of how the things are going to be in the request. So we say string name because it's of type string, and ISBN, author name, and price. So price is of type int32. So we don't have int, but we have int32 in proto buffers. So we give 1, 2, 3, 4. So we can also write the same thing in a different manner. So we could do one thing. We could this book request will contain a variable called book of type book. So what is this type book? We'll be defining that again, which we have defined before, but we have just separated it just for organizability and reading purposes. But this looks much better. And here we start with 1, but here for every structure it starts with 1 and goes on. So we could do this. This is a better way of doing this. Next, I want to talk about what we'll be building in this video. I'll be building a very small API using gRPC, and we'll be building a HeartBeat API. HeartBeat API in the sense we'll be having a client and a server, and it's just a request and response from regarding HeartBeat. So it sends an HeartBeat request, then we receive an HeartBeat response. So this is an unary. Similarly, we have for client streaming service, and we have Bi-Directional streaming service, which you have seen before, and we have server streaming service. So we will be building this. We'll be coming back to this when we're building the application. So I think we can get started with the install proto-c, or you could say ProtoCompiler. You can just Google it, proto-c, and you can just download the first you could just click the first link where you'll have all the documentation for completing the installation. For as I'm using Mac, I could easily do preview install protobuf and then use proto C version. There is actually many installation options for this. If you're using Windows or Linux, any of this, you could just install this. You could actually find your Go path by saying echo Go path. So that gives you the Go path where it exists. And inside that Go path, you could just do src and it would go into your src directory where all of your project can be made. So I'm inside my src folder, if you could see that. Yeah. And what I want to do is I want to create a folder named HeartBeat and go into cd into that. Right now there are no folders. I want to create let me create the first folder, which is HeartBeat_pb. So pb stands for ProtoBuffer. So let's go into that directory and let's edit let's say heartbeat.proto. So we have this proto file which we have seen previously. We are going to be defining our services here. So first thing we need to be saying is we are using which version of proto we are using. So you have to say syntax is equals to proto 3, and we have to make sure that this is ending with a semicolon because it's very strictly typed. So next I want to define what the package is. So the package I'm going to name this, I'm going to name the package as heartbeat_pb, and next we can set an option which says go package is equals to where this exists. So it's the /heartbeat_pb. So this is where this proto file exists. Let's save this and let's quit and let's go back. We have one directory. Now I want to create another directory, let's say heartbeat_server. So this is going to be the server part, which is going to be handling the server stuff. And let's cd into heartbeat server and let's create a file called server.go. First thing is that we need to listen to port. By default gRPC listens at port number 50051. So let's try to connect that. We could do that by saying let's say list error, which is, we could say just net.listen. First thing is we need to specify the type of connection and the address of the connection, which is localhost 50,051. And I actually want to define a function. So usually what we'll be doing is that in Go we need to use every variable. So we have to listen for errors. If error is not equals to null, then we can say log.fatal of error. So we could just use that. Let me save this so that it automatically imports the packages for me. But I want to write a function here so that I don't want to handle error every time. I just want to call this function. So it is of type error. And what I want to do is I just want to move this here. And now I can just say handle this error and send the error into this. For this project we'll be using MongoDB. So we also need to do we also need to install MongoDB. So if you can just go to this, you can just do go get this. So you can just go to MongoDB driver and you can just do go get this URL in order to install MongoDB or Mongo driver for your project. To set up MongoDB, what I can do is I can just say client error is equals to mongo.new client, and I want to create this client by saying options.client array, which is going to be a MongoDB URL, MongoDB localhost, and the default server port of MongoDB is this 27017, and then close it. And if I save this, it will just import the options for me, and I can handle the error here by saying handle error. I want to create a global variable called collection, which is of type *mongo.collection, so that I can actually use this to create collections or to make queries. because we'll be using functions, I want to keep this as a global variable. If there are no errors, what we can do is we can just say println MongoDB connected, right? And we can say error is equals to client.connect, and we have to send a context here. We don't know what the context is, so we can say just say to do if we don't know what the context is. We can again handle the error by saying handle error of error. So after connecting this, we need to connect to a database because we haven't defined our database yet. We can just do that by saying collection. We can just assign the collection variable here by saying collection is equals to client.database. Of which database you want to connect. I want to connect to HeartBeat database, and dot collection, which collection inside the database. So that's also going to be HeartBeat. Let's go back to that proto file. Let's say pb/heartbeat.proto. Let's define our first request and response. So here we have client and server, and there's a HeartBeat request and response. So let's go and define that. So first I want to create a type of HeartBeat. So what this HeartBeat consists is that we'll be using this HeartBeat for every request and response, or maybe or not, but most probably if we want to know the HeartBeat, then we have to use this structure. So the HeartBeat contains BPM, which is of type, let's say int 32. BPM is equals to 1. So this is how you define variables in Proto. You say the type, and then you say the name of the variable, and then the number, which should be unique and in sequential order. The username, to which this BPM should belong to some user. So here's the username. We'll not be doing any authentication stuff, but we need something to uniquely identify to whom this BPM connects. Let's say the first HeartBeat request. So you can say HeartBeat request, and we are going to have, in this request we are going to have one variable of type HeartBeat, and the name is going to be HeartBeat. We have to give 1 here, so is equals to 1. And similarly we'll have HeartBeat response. So here it's just going to be a string called result is equals to 1. So what we are going to do is we're going to send the BPM and the username of the user, and we're going to send it as a request. And for response we'll be getting just a string, because we'll be storing this in MongoDB, the request data, and then we'll be sending the request stored, or we could say the heartbeat of BPM so and so has been stored. So that's a response going to be. So it's just going to be a string. So we have defined our request and responses, but what we need to do is we need to define our service in the sense we need to define our functions. So you could do that by saying service, and let's say HeartBeat service. So the way to define service or a function is that you need to have an RPC keyword before the function name, and after RPC we have the function name. In this case it's user HeartBeat, and this is going to take one argument, which is our HeartBeat request, and it returns, that's another keyword. We need to return something, and you could say this. So we are going to need to return a response, right? So we could just return the HeartBeat response. So that's it. This is going to be our first service, which we haven't yet run this, but you could say we will be building this. So let's quit and let's see what's actually inside. Let's come to the root directory and let's see what are all inside this HeartBeat_pb. This is one proto file. Right now this is just one proto file. So what we need to do is we need to compile this proto file so that we can generate what we say as stubs. So you could do that by saying proto c, where the file exists. So it's at HeartBeat/HeartBeat_pb. That's the directory where this HeartBeat.proto exists. And we need to, right now we are using Go, so we need to put those plugins here. So you can say --go_gRPC -out So dash dash gRPC, it's underscore out is equals to colon dot. So that's how you compile this. So that's for gRPC output. So we need to add another flag, which is dash dash go underscore out is equals to colon dot. So this is two flags, which is to generate two files. So it says let's change this to heartbeat pb. So it's saying it's giving us an error. Let's see what we have forgot. We forgot an semicolon. So let's go into the proto file, and here we forgot a semicolon. Let's save that, clear the screen, and again run. Should actually be dash, not underscore. And now it executes successfully, and let's see what is inside heartbeat underscore pb. So before you were compiling, we had one single file, but we have now two more files which we have seen, .pb.go and underscore grpc.pb.go. Let's see actually what that contains. So let's go into .pb.go. So there is so much of gibberish here, but one thing you can see is that we are seeing some entities which are familiar to us. There's a heartbeat structure which has some auto-generated fields, and also there are some fields which are given by us. So there's a BPM and username field of int32 string, and we have some functions, built-in functions. We can use that gset string or some others. So get username, get BPM, these are some functions defined in this file. So we could use that in our server file. So we have a heartbeat response structure. We need to have results. You can also see that every first letter is capitalized, so that needs to be taken care of. And there's get result, and there's a large byte file. So there's nothing to know about this, but this is just all auto generated. So let's also take a look at heartbeat underscore gRPC. So here there is there are some interfaces, and each interface needs to be implemented by us. So right now you can see that we need to create a server here, HeartBeatServiceServer, in our server.go file. That should contain two functions, or you could say two functions. One is the user heartbeat, and second is this must embed unimplemented HeartBeatServiceServer. It's quite a long name, but we need to include this too, or else it would be giving us an error. So this is what we need to build first. So this takes context and a heartbeat request and returns a response and an error. So let's go build this. So let's go back to our server file, and even before starting to build this, we need to import our gRPC library. And as I said, you could go to that URL gRPC go, and you can just go get this URL in order to install gRPC. We can initialize our options here. Options is equals to gRPC dot. Now you can say you could create an array of gRPC dot. It's an array of gRPC dot server options, or its server option, and you can send this into a variable called s. So you could say gRPC dot new server and options. So we are sending this, and we are creating a new server variable. So let's save this and import, so that it imports it. We can use this s variable to connect to gRPC. And before even if you take a look into heartbeat underscore gRPC, there is a function saying register heartbeat service server. So we need to, even before using this interfaces or something, everything inside this, even before using the entities inside this, we need to register the heartbeat service server. So we have to do that in our server.go. So we could go here and just say heartbeat underscore pb dot register heartbeat service server, and this takes s and a server variable. So we can say ampersand server. We haven't created this server. So as I said, this server has an interface which needs to complete those two functions, right? So we need to create that. So let's create that struct. It's actually type server, which is of type struct, and it needs to have heartbeat pb dot unimplemented heartbeat service server, which we have seen, and also it needs to we can just this is enough for now, and let's save this, and we have registered to that server here. Error is equals to s.serve of the listener, and we can just handle error by sending error. So we can put this into a if statement. If error is not equals to null, handle the error. Let's save this, and let's open a vertical window and try to run this. Let's say go run HeartBeatServer / server.go. So we can actually put this inside the go function, and we'll just put it inside like that. So we have defined our collection database, and what I want to do is I want to create a channel here. So we can make a channel. Let's say chan os.signal, and this channel is of size 1, so that whenever we close our server, we also close our MongoDB server. So we can just say signal.notify ch, os.interrupt. So why we're doing this is that it notifies the channel whenever there's an interrupt occurring. So let's save that, and let's just say this ch. What this does is that this blocks until we receive an interrupt from our keyboard, which is Control C or Control D in our case. So after it receives an interrupt, the whatever below gets executed. So what I want to do is I want to print a new statement saying closing Mongo connection, because we will be closing the Mongo connection. And let's say if L is equals to client dot disconnect, and it needs a context. So let's again send context to do, and the error is not equals to nil, then handle the error, send the error here. So after that we can just say s.stop, which stops the server. So let's try to run this. So now we can see that it's MongoDB is connected and the server is running. So whenever we say Control C, it gets an interrupt and it closes the Mongo connection. So that's what is happening here. So we have our basic server running here. So now we can implement that user heartbeat function. So we can create a function. So let's say user heartbeat, and let's see what it has here. Heart beat. So in this, let me bring that down here. So in this interface, we are having user heartbeat, and it must implement, it takes context and heartbeat request as parameters. So let's say ctx is of type context.context, and the request, we have a request, and it is of type heartbeat underscore pb dot heartbeat request, and this also has a response coming in. So we can say heartbeat, it's of type pointer, so heartbeat pb dot heartbeat response and an error. So you can see that this is inside this server, right? This is inside this server. There are these two functions. So we have only implemented one function. We have defined the function, but we haven't tied this with this server, right? So to do that, we can just use the receiver functions in Go. So you can just say server here, so that it ties up with this structure. Let me close this, and now you can define whatever is inside this server. So for now, let me just return nil and nil. It actually throws an error, but it's okay. And I want to just print ln the request which is coming in, and I quit this. And right now we have two directories, server and proto, but we need to create another directory named heartbeat_client, and let's say heartbeat_client/client.go. We need to connect to gRPC first. Let's say connection error is gRPC.dial. So dial in the sense whenever we are making a request, make the request to this URL. And usually gRPC needs to be in SSL mode, but we are not going with SSL because in localhost we don't have SSL. So we can just pass an flag saying gRPC.with insecure. So it makes sure that even HTTP is accepted. So again we need to let's define the handle error function. It takes an error which is of type error, and then log dot if error is not equals to nil, then we can just say log dot fatal of error, and here we can just say handle error of error. Let's save this so that it imports everything for us. You can just say connection.close so that it's actually capital C, so that it closes whenever whenever this main function ends. So we need to create a client. So we need to create a client for this server to make communication or make calls for the server. So to do that, we can just create a variable C, and we can just say heartbeat pb dot new heartbeat service client, which takes connection as a parameter. Let's save so that it imports. The heartbeat_pb has a function called new heartbeat service client. What this does is that it creates a new client and it returns it. So we can store that at C, and we can make calls using this C variable. If there are no errors, we can just say client started. We need to do that for server so that we can know that server is running. So the first let's create the first function, which is user heartbeat. So we need to use this C variable in this function. So let's take that here C, and this is of type heartbeat pb.heartbeat service client. This. So in order to make a request, let's save this. Let's go into proto file which I have created. So the request should be of this type, right? So it should be of type heartbeat named. We need to have a variable named heartbeat, which is of type. Again, it's of type heartbeat. Create that request. Let's say heartbeat request. Let's close this. Is equals to heartbeat pb dot heartbeat request. So we have this built-in. We have seen the structs, right? For heartbeat request and heartbeat response, we have that struct, so we can just create a new struct which is of type heartbeat request, and this heartbeat request in turn has another struct which is heartbeat, right? So we have another heartbeat which is of type heartbeat pb dot heartbeat. So now we can define our variables. We have bpm and our username. So let's say bpm is 75, and the username is my name, which is Mano Sriram. It takes a reference, so we need to send an address, not the struct itself. So again, as I said, in the proto file, if you have seen, we have given all small letters, but whenever it compiles it, the first letter is converted into a uppercase one. So we need to make sure it's uppercase here. So let's save that, and we have this request with us, but we need to send this request. So to send this, we can just make use of this C variable here. We can just say C dot user heartbeat. So this is a function which we have defined, right? So it takes a context, which is context dot background in this case, and the heartbeat request. So this c.userHeartBeat, we are calling this function because we have tied this using the receiver function, if you remember that. So we just call this. So let's actually open another tab. Let me open another tab and let me split this into 2 panes. And on the left side there is the server. I will be running the server. So heartbeat_server/server.go. And on the right side I will be running heartbeat client/client.go. We have an error. We haven't used the c variable here. It's because we haven't called the function itself. So you can just call this function userHeartBeat and send c in here. So let's call the function again. Now you can see that on our server we received the response, which is heartbeat with BPM and username, but also we received an server error. It is because, as I said, we are sending the response as nil and the error as nil. The error can be nil, but I think this both should not be nil, because nil, this response is a pointer, so it needs an address, so we should not send nil. We need to send at least an empty response, but not nil. So now what I want to do is I want to store this request here, this BPM and username into MongoDB. So let me write a function for that, so that I can just use this function to push any data into Mongo. So I can say push user to DB, and this takes the context, because we need context to as a parameter for Mongo queries, so we need that. And the second is the item. So here what needs to be defined is we need to have a if you have worked with Mongo collections, then we need to define a model for Mongo. So we haven't defined that yet. So let me comment this and just say, let's say heart item, which is of type struct. So this is going to be a model for our collection. So in our collection we are going to have an ID which is primitive.object ID. What it means is that it is just a type object ID which MongoDB offers for us automatically. So this we are going to have bson and underscore ID which is automatically generated by MongoDB, and we can put a comma and say omit empty and just close it. So that's an ID for us. And we can next have BPM which is of type int32, and this is going to be bson BPM, close it. And we also have username, which is of type string, and we can say bson and username. So this is what we're going to have. So these three things is a bit just to keep things simple. So let me uncomment this, and item is going to be of type heart item now. So what we'll be returning is just a primitive.object ID, because I will be returning the ID of newly created object. So now what I can do is I can just say res error is equals to collection dot insert 1, and I can send the context and the item. So I can just handle the error here. So that's what push to DB is, and we can just return res.id, inserted ID. But this is of type this is not in a match with what we are sending. This is not a primitive.object ID type, so we can just convert it like this, and that's it. And here we are having request here. We need to take BPM and username out of this request. So we can say BPM is equals to request dot get heartbeat, it's a function, and dot get BPM, it's a function. So one of the pros of working with protocol buffers is that we get these inbuilt functions for our protocol buffer variables, so that we can just take them out. So we have a username here similar to this, request.get heartbeat.get username. So we have these two variables, and I want to create a new struct here, which is of type heart item. So let me say new heart item is equals to heart item, which is going to have BPM, which is of BPM, and username is going to be our username. We need to put a comma here. And what I want to do is I want to push this into DB. So I can just do doc id is equals to push user to DB, and I want a context. I can send this context which I am receiving here, and after context I want to send this item. So instead of this item, I'll just send the new heart item which we have just created. So now that we have inserted our document, we need to send some response back. So what I will be sending is I'll be sending the document ID with some other string. So we can just say fmt.sprintf, just to keep things simple. I mean, I'm using sprintf because it makes formatting easier instead of adding this plus and things. User heartbeat is some value, and newly created doc id is another some value. So the heartbeat is BPM, and newly created doc id is doc id. So I'll just return this result, but you can't just return the result because this is of type string. The result is of type string, but we need to return heartbeat response here. So what we'll be creating is that let's say heartbeat response is equals to heartbeat pb dot heartbeat response, and inside this we have a result. That result is going to be this result, and a comma here, and we'll be sending heartbeat response. And make sure you are sending the address or the reference of this response, not the response itself. So the reason we are adding the result like this is that if you go to the proto file here, we have the response. Inside this response, here we are returning the response. We are not returning the string result itself. So we have to create a response, and inside that response we have to put the result. So that's why we are doing so much of this. Restart the server, and while it starts, let me go into my Mongo CLI. Okay, and I want to use the database heartbeat. I'm not entering it, I'm just keeping it. So my server has started and I'm running my client. So the client has started and it exited, but there's nothing from HeartBeat server because we haven't put any indication for the HeartBeat server to acknowledge it. So we can just say here println heartbeat, or you could say user heartbeat called. Okay, and let's restart the server, and when it restarts we can just send another request. And now we can see that there is a user heartbeat call. So now let's go into MongoDB and let's use the heartbeat, new collection heartbeat. So we can say heartbeat dot find. So now you can see that we are having two different, we have two entries in our Mongo database. So it works. So we have finished building this first unary service, and now we can move on. In this case, just to remind you, we are just sending a single heartbeat request and response. There's no streaming here. Now let's go to stream from the client. So for this, you can see this heart is beating. It's a GIF. And this heart is static, which means that this is not going to stream. This is going to stream on the client. So let's send a stream of heartbeats requests from the client, and then we can just respond a single response after all finishes from the server. We are finished with our unary service, which is heartbeat request. Now we are going to build our second service, which is LiveHeartBeat. So let's define our service here, which is LiveHeartBeat, and this takes LiveHeartBeatRequest as a request and returns LiveHeartBeat response. So this is the service we're going to define, but we need to define these two request and response variables. So let's go here and just define similar to what we had done before. So let's say message LiveHeartBeat request. So this is actually similar to what the heartbeat request is. We'll get a heartbeat request of type heartbeat, which is equals to 1. But now the response for this LiveHeartBeat response, so the response is also going to be a string, but this is a different type of string. You may ask, like, if everything is similar here, then how we are going to stream? I mean, isn't there any difference for when we are creating the proto file? So there is a difference, because we need to change this service which we have defined here. So we are saying LiveHeartBeat request and returns a response. But when this request is not going to be a single request, right? We are going to get multiple requests from the client. So we need to add a keyword called stream before this request, so that there can be multiple streams coming as a request. So let's first go to a client. And let's go to a client and let's define a function, new function, which is LiveHeartBeat. This is also going to take heartbeat pb dot heartbeat service client. So what we're going to do is we're going to send multiple requests from our side, from the client side, and the server will just create a string saying the user's heartbeat is so and so and the doc ID is so and so, and it keeps on appending the new string, and finally it just returns as a single string. So if you don't get what I'm saying right now, it's okay, because we'll be just seeing what to do. So what I'm going to do is I'm going to run a loop. Let's say for t starts from 0 to 10, and for every iteration I want to send a request, or you can say send a request to the client server. So for that to send a request, we need to create a new request. Heartbeat underscore pb underscore pb dot LiveHeartBeat request. We are not getting any autocomplete because we haven't compiled that, because we have made some changes to the proto file. We have to again compile that. So you could just go to proto C and just run the command again, LiveHeartBeat request, and this is going to consist of a heartbeat. So let's say heartbeat, and that is in turn it's going to be a heartbeat pb dot heartbeat. So in this heartbeat we need to send a BPM and a username. So username is going to be same Mano Sriram, because I don't want to change it. But the BPM needs to change. We can, instead of just sending a static number, we can just generate random numbers. So let me create a generate BPM function, and what this does is that I create a BPM variable here, and I can do rand dot int n, and I can take up to 100 here, and I can just send the BPM back. This takes int32 as a response back, but we need to convert this into int32 to send this. And now at this BPM I can just say generate BPM, another comma here, comma here. So we are sending this. We are creating this request, but we are not sending it yet. Before even sending the request, we need to create a stream from the request. So stream comma error is equals to c dot LiveHeartBeat and context dot background, which is by default, and we can just handle error here. And stream, now we can just do stream dot send this new request. And after everything is done, after there are 10 requests sent, we can just close the stream. So we can have a response and error, and we can just say stream dot close and receive. So what this means is that it's close the stream. It indicates that the stream is closed to the server, and then it waits for the response to arrive. So let's handle the error here. And it waits for the response to arrive, and we can just print that response here. So it's giving me an error saying LiveHeartBeat is not implemented yet, but we'll be implementing this. Let's go to HeartBeatServer, and let's create the second function, and let's tie that to server. The function name is going to be LiveHeartBeat, and this is going to take different parameters than the previous one. If you go into the gRPC file, so you can just search for LiveHeartBeat. This is the service. This is the client one. We need the server, or you can just server. Yeah, we have this LiveHeartBeat, and this time previously we had context and heartbeat request going in, but this time we have just one thing saying heartbeat service underscore LiveHeartBeatServer. So what this means is that they're just giving a stream of request. So you can just say stream and heartbeat pb dot heartbeat service and underscore LiveHeartBeatServer. So this might be a bit long naming conventions, but it is automatically generated, so we can't do anything about that. So what I'm going to do is I'll be continuously receiving. If you remember what we did in the client file here, client.go, we said this, we call this function close and receive. So until this function is called, we'll be running a loop and we'll be receiving messages on and on. So let me run an infinite loop here for this, and I'll be receiving the message using this stream variable here. So I'll be saying message comma error is stream dot receive. So it's like if you have used C to read a file, then we reach the end of file, right? So similar to that, we reach the end of stream here whenever we call that stream close and receive from the client side. So we can just check if error is of type io.eof, then we can just break it. I want to handle error here. What I want to do is from this request, I want to get the BPM and the username out, and I want to create a new MongoDB document. So we can just do that by saying doc id is push to db, push user to db, and I'll be saying context.todo because we have no context from our client coming right now. So we'll say context.todo, and we'll be creating a new heart item. There is no reference, so we'll be creating a new heart item that contains BPM, which is message dot get heartbeat dot get BPM, and the username, you would say username is going to be message dot get heartbeat dot get username, and there's a comma here. And what I want to do is I want to have a string here. Result is an empty string, and for every iteration, what I want to do is I just want to say result will be appending a new string. So let's say as printf user heartbeat is equals to this, doc id is equals to this, and I can just say the user heartbeat is what it's BPM. We have not defined that. Let's just copy and create a new variable out of it, and the doc id is doc id, but we need to I think it's enough. Let's do this for differentiating all this. Because we are appending many strings, I just want to make sure we can separate them. Let's run the server, not the client. We are actually not returning anything from this function, so that's error. So we'll be returning an error whenever I reach the end of the file, or you could say end of the stream. I want to return this result back, so I could just say return heartbeat underscore pb dot live heartbeat response, and I can just say result is going to be the result, this string which we have used till now. So instead of return, we can actually say stream dot send and close. There's a function called send and close. So what it does is that it sends and it closes the connection. And I can just put an ampersand here, and I can compile this again. So it's running, and we can send. Actually, we need to call the function again in the client. So if I open the client.go, there's a user heartbeat. What I want is live heartbeat of C. So when I run this, you can see that I'm getting this account. I think I'm getting like 10 responses back. You can see that I have differentiated it by these dashes. I just want to make a statement here. I want to create a new line, and I want to say request sent, and I want to say new request. So I don't want to print the response. Let's run this again. Okay, so we haven't. Yes, we can just put an underscore so that we don't need to use that. Or you could say just stream. So let's run this again. So now we can see that we are generating these random numbers for BPM, and we are also sending the heartbeat. So let's go into MongoDB and just find this again. So we can see that everything is inserted here. So this is what client streaming is. We are not seeing anything in server because we are not printing anything. So I'll just print the stream here inside, or I'll just print the message which you're getting from the stream. I'll run the server file, and I can run the client now. So you can see that we are getting this, and finally when we get nil, that's when the stream is closed, and the client knows that. So that's how live heartbeat works. We send multiple streams of live heartbeat request, and we got a single response from this. So the single response we got from the client is just a single string of them all. So that's what we got in return. So we have done unary and client streaming. So now I think it's time to move to server stream. So this is really similar to what we have done before. It's just you have to stream it from server instead of client. This server streaming, it's known as HeartBeatHistory. What we're going to do is that we are going to send one single request with the user's username in it. The server is going to return all the documents whose document relates to this username, or you could say whose BPM belongs to this username. So let's go to heartbeat pb / heartbeat.proto. Heartbeat.proto, and we need to define a new service now. So you could say RPC, similar to that. So we're going to say heartbeat history, and this time we are not going to receive a stream of requests. We're going to only receive one request. So it's heartbeat history request, and which returns a stream of responses. So we could say heartbeat history response. That's it. So we need to define these response and requests. So we could say message heartbeat history request. So the request is quite simple. It's a string with the username is equals to 1. We only need the username, and the response is going to be, let's say, heartbeat history response. the response is going to be of type, we're going to return a type heartbeat with a name heartbeat. It's heartbeat, which is 1. So that's it. It's actually reverse now in this case, because we are using response. We are going to send a response of type heartbeat, so the response must contain the BPM and username in it. So that's what we're going to do. So now we have done this, we need to compile. We should not forget to compile this. So let's compile this, and then we can start from the client side. Let's just send one single. Let's create a new function first, and let's send the username in it. That's it. And let's say heartbeat history, and this is going to be the same heartbeat pb dot heartbeat, what was that, service client. So what we're going to do is that I'm going to create a new request, or you could say new history request. This is going to be of type heartpb dot heartbeat history request. So this needs to take this takes a username. The username is going to be Mano Sriram, and we're going to send this to the service. So we could just say c dot heartbeat history, and the context is context dot to do and new history request, and make sure you send it with it as a reference, so put the ampersand symbol before the request. So this is actually context dot background. So we can just send this, and after sending, what we need to do is we need to wait for the responses, or we need to receive the responses until, or how many, we don't know how many responses the server is going to send, so we need to receive all the responses. So for that, what you can do is this heartbeat history returns a stream, so you can say res underscore stream, which is equal to this. So now we're going to do a similar infinite loop, and for this, similar to the client streaming, we are going to say res stream dot receive, which will receive the, let's save this first, which will receive the stream details. So we can handle the error here, and if error is equals to io dot eof, then I want to break. I just want to print the message too. So it's quite simple for the client side, because we are just sending a request, that's it. So now let's go to the server, and let's let me go up. Let's create a new function and tie that to server, and it's heartbeat history, and let's see what they have defined in the gRPC proto file. And let's do server, search for server, and we have heartbeat history function here. The first argument is the heartbeat request, and the second argument is our stream. So there are two arguments coming, and we can just return the error. So the first one is going to be the request, so it's request of type pointer type heartbeat underscore pb dot heartbeat history request, and the second one is going to be stream of type heartbeat pb dot heartbeat history, not request but underscore heartbeat history client, sorry, server. First I want to acknowledge this, so I want to say heartbeat history call, so that we know this is being called here. And let's say this request actually contains the username which we sent from the client, so we can just grab that. So we can say request dot get username, and now what we're going to do is we're going to query Mongo to get all the documents which has the username in it. So what I'm going to do is I'm going to when we have created this heart item which has the structure or the model for Mongo database, and this we have many documents, or you could say we have multiple documents with this username, right? So we need to first store these results somewhere, so we need to create an array for that, or you could say a variable for that. So we could create an array of heart items, so that whatever the results are, we could just store it in this result. So what Mongo has is that it has cursor comma error. Let me show you what it has. We could do collection dot find, and what we need to find, it has a context first. Let's say to do context, because we don't know what the context is, and because we are not getting context from the client side. So that's a context, and we need to send a filter here now. Oops. So we need to send a filter here. So we don't know what the filter is, but we can define the filter here. So this filter is going to be bson.m. So M stands for map. So we create a map. So we want to have a username which is of value username. So this username stands for the key, and this is for value. So the value is what I'm getting from the client right now. So I'll send that filter, and I'll handle the error. Now we have something called cursor dot all, and what this takes is that it takes context dot background, and we can just send the result, or you can say the reference of the result data, which is, or you could say result. You can just rename this to result data, and we can send its reference, so that whatever we get, the results we get are put into this array. And now we can use this array. So what I want to do is I want to loop through this array. So I can say I don't want the index, I just want the value in the range of this result data. What I want to do is that I want to stream this result data or the value to back to the client. So for that I need to create a response. So let's say history response is equals to heartbeat underscore pv dot heartbeat history response. So if you remember, we have the response, inside that we have another heartbeat, and this has heartbeat pb dot heartbeat, and now we have bpm, which is v dot bpm, and we have the username, which is v dot username. So of course we don't need the username because this is all we are getting back. So we can put the commas. Now what I can do is, for every iteration I can just say stream dot send this history response, and I'm sending the reference again. I mean reference in the sense I'm sending the response with an ampersand. We need to say there is no error, so we can just say return null. Actually we need to put that here. I need to define it expects a return type error. So I think we can test this now. Let's go back here. Let's restart the server, and now we can run the client, but I think we haven't called the function now client. So live heartbeat is complete. Now I think it's heartbeat history of C. So we can go and just run the client file. We need to handle the error. So we can run this again. So you could see that we are getting our heartbeat history call, and we're also getting this response here, and you can say we're getting many documents for the username Mano Sriram. So yeah, that works. So this is being streamed actually from the server side. So if you have if you want to see if it's really being streamed or not, you can just put a time.sleep here, and you can say 1 into time.second. So every 1 second it sleeps and then prints the message. So that would be, then you can really see it's being streamed. I mean, it's just a graphical thing. You could see that it's being, I mean, this is what we have actually received, but we are sleeping and for 1 second. So this is right now what we are receiving. I finished heartbeat history, And next is the final one, which is our bidirectional streaming. We are calling it normal abnormal heartbeat. So in this case, will be sending a stream of requests, and then server would be responding to all those requests. It will be, I mean, both the sides, they'll be streaming back to back. So in our application, what we are going to do is that the client would be sending a request with a BPM, and the server would be sending back if the BPM is normal or abnormal. So let's say if the human's normal heartbeat BPM is 60 to 100, then if the client sends 100, 110, then the server must respond it's abnormal. So let's update the proto file for that. We are going to have the final RPC, for which we are going to bidirectional stream here. So we can say normal abnormal heartbeat returns something. So if you have seen, for client streaming, we are putting the stream variable before the request, and for server streaming, we are putting the stream variable before the response. So for bidirectional streaming, it will be a combination of both. We will be putting the variable stream for both request and response because both server and client are using this stream variable. So we could just say normal abnormal heartbeat request. The naming is getting quite long, but I think it's okay, and returns a stream of normal abnormal heartbeat response. And let's save that. We need to define that here. So let's say normal abnormal heartbeat request. So the request is going to be single thing, which is the BPM, which is going to be of type int32. I think it's int32 BPM is equals to 1. And the response, let's say normal abnormal heartbeat response, is going to be a string, because we'll be, let me tell you, because we'll be sending a string saying given BPM is normal, or if it's abnormal, we'll be saying given BPM is abnormal. So that's the only thing we'll be doing. So let's we have defined this. Let's go back and compile this. That's an important step, and we have compiled it. So we can go into the client first to write the function. So it's normal abnormal heartbeat, and it takes heart pb dot heartbeat service client. What we did for client streaming is that we ran a loop and streamed inside. For every iteration we streamed it. So similar to that, we can do something like this. So for every iteration, I want to create a new, let's say normal abnormal request, so which is going to be heartbeat underscore pb dot normal abnormal heartbeat request. So there will be a BPM for this, and this is going to be generate BPM. I want to send this in a stream, so I can say stream dot send and new NA request. I can just send that. So we need to have a stream variable for this, so we need to call that here. So similar to what we have done before, it's stream comma error, which is c dot normal abnormal heartbeat, and it takes a context, which is context dot background, and we need to handle the error. So we have this, so we can just print a line here, sent. I can just do printf sent a value, and that is going to be new NA request. Oh, there should be a comma. We need to close the stream, so we need to say close stream dot close or close send. It's new NA request. We are sending request, or we are streaming from the client side, but we also need to receive from the client side at the same time. So let's go down and let's listen. For server streaming, what we did is that we have received, we put an infinite loop and we listen for until the server sends send close flag. So until that we were streaming, we were receiving for the whatever server was doing. So similarly we can do this here. You can say stream dot it's receive, and if error is equals to io.eof, then you can say break and just break out, or else you can handle error first, and then you can say print ln, or you could say printf received the value, which is message. So let's see what happens if we send this, but we need to define the server file also. We need to define the function. So let's create a function here which is of type star. Let's attach it to server, and let's say normal abnormal heartbeat. So for this, we are, because this is streaming, bi-directional streaming, it is also server streaming because it's a bi-directional streaming. So we'll be receiving a stream of type heartbeat underscore pb dot heartbeat service underscore heartbeat is normal abnormal heartbeat server. So this is quite a long name actually. So now what we do is, for server streaming, previously what we have done, similarly we can just listen for client, for client streaming, what we have done, we just listen for whatever the client is sending. So we do the same here for request and error. I'll just say stream dot receive, and if error is equals to io.eof, then you can just return nil. Speaking of which, we need to return an error here. We are getting the BPM from the request, right? So we need to get that out. Let's say request dot get BPM, or you could say, we could say just get BPM. So let's create a variable result which is of type string, and we need to check if this BPM is less than 60 and BPM is greater than 100. If it is so, it is abnormal. So we could say result is equals to, I would say fmt.sprintf user heartbeat of, I can just put this like this, of so and so value is abnormal, and the value is BPM. Or else I would just copy this, is normal, and I can just stream this back to the client. I can just stream.send result, but it would not go because you need to send it in a form of request. So we can just say response, or you could say normal abnormal response is equals to heartbeat pb dot normal abnormal response, and it contains a result which is this result, and here we send the NA responses. So this, we comment this out and we say normal abnormal heartbeat of C, and we go to the server and run the server. So what needs to happen is that the client needs to send a BPM and the server needs to respond if it's normal or abnormal. So that's the result we are expecting. Let's run the client file. It's because we are getting this should be an address here itself instead of here, because when we are printing this, it is printing this request itself. So we need to print the reference. So moving this here or here, removing this and putting it here, I think it's the same, but just for printing we're just putting it here. Let's just print it up here. Let's say fmt.println normal abnormal heartbeat called. I think this condition is wrong, it should be OR. So we can just run this again after restarting the server. So we're getting the results back. So we sent this BPM and we are receiving the result back. So what we can do is we can create a Go routine and put it you can create a Go routine and put this block of code into that Go routine. So instead of putting a separate function, we can just call the function with a Go keyword here. So create a function and call it right there. But if you know the problem with Go routines is that it spawns this in a new thread and it goes down. So this finishes this function and then this thread is also gone, poof, like that. So we need to make sure that this function waits for this function to end. So what we need to do is we need to use wait groups or channels to make this happen. So if you have seen my previous video, you can get a reference for how to use wait groups. So let's create a wait group variable. So let's say var wg is of type sync.waitGroup. So we can say before this go function, we can just say wg.add of 1 because there's just one go routine. I'm going to spawn. So whenever after this I'm going to do wg.wait to wait for the go routine. So whenever I hit the last page or last end of file, instead of I break from this function, but also from this loop, but also I will say wg.done so as to indicate not to wait. Let's put this here. So sending back response, which is the result. Oops. So let's restart the server. And we can see that this results which we have received and which we have sent and which we have received are in sync. So the part which is to be focused here is the bi-directional part where we are streaming back to back. So that's the one we need to focus on, and I think that is what I wanted to say in this bi-directional video. I know this is quite a long video, but I just wanted to make sure that this concept is implemented in the right way. So there are much more depthly concepts in this gRPC. I mean, it's a very wide topic, but there are deadlines and there are SSL. There is SSL, there is deadlines, and there are much more. I think handling errors in gRPC, that's very important. But I'll be making a separate video on that because this video has been so long. So I just want to keep it short. I mean, it's already long, but I just want to stop it here. So I think that's it for this video, and thank you for watching. Make sure you like, share and subscribe this video. Thank you.